So this next question, we've got another redox titration to practice. So let's write out our usual steps. So first step is to work out the equation. So what we've got here, we've got hydrogen peroxide, and that's reacting with potassium manganate. So hydrogen peroxide and potassium manganate. So your equation here is the hydrogen peroxide going to OH minus, and you've got your manganate ions going to Mn2 plus. So we need to balance. So this top one's going to be 2 OH minus, and then you're going to have 2 electrons on the hydrogen peroxide side. And in the bottom one, we need to add 4 waters, need to add 8 H plus, and 5 electrons. So in order to balance the electrons, you need to multiply the top one by 5, and we need to multiply the bottom one by 2. So the ratio of manganate to hydrogen peroxide will be 2 to 5, so we need that a little bit later. Our next step is moles. So what can we work out a number of moles of? We've got 24.35 of a 0.0187 mole per dm cubed solution. So we can work out moles of the manganate ions, which equals 24.35 times 0.0187 over 1,000, and that gives you 4.55 times 10 to the minus 4. Then we can use the ratio that we've just worked out of 2 to 5 to work out the moles of the hydrogen peroxide. So moles of H2O2 will equal 4.55 times 10 to the minus 4 divided by 2 times by 5, which equals 1.138 times 10 to the minus 3. Now, as ever, that was taken from a 250 centimetre cube sample, and 25 centimetre cube was taken from it. So number of moles of H2O2 in 250 centimetres cubed equals the 1.138 times 10 to the minus 3 times by 10, which equals 1.138 times 10 to the minus 2. Then this is where we just step back and reflect. So what we're actually trying to work out, we're trying to work out the concentration of the original hydrogen peroxide. So our triangle is going to be the one with concentration in, which is moles equals concentration times volume. So we need moles and we need a volume. Well, our volume is right here, 5 centimetres cubed, and our moles is right here. We've just worked it out. So our concentration of H2O2 is going to equal number of moles, which is 1.138 times 10 to the minus 2, divided by the volume, which is 5 centimetres cubed. It's going to be 5 divided by 1,000. Do that in brackets so that you don't get a weird number. And so what you will get in the end is 2.28 moles per dm cubed.